Well, hello and welcome to skill lesson 17, none other than the ruler postulate and segment addition postulate. These two postulates are very much connected, dare I say even correlated postulates. And remember, just a postulate is something that is accepted as true without proof. So we're going to look at two postulates today, the ruler postulate and segment addition. And again, they are very much connected here. So as always, we're going to jump through these examples and move right on to the practice. So for our practice on the ruler postulate and segment addition postulate skill lesson, number one says find the length of each line segment. So what they've done here is they've really been utilizing the number line and applying it to a more geometric way to look at it in terms of a line segment. So, and this helps us with our understanding of distance and the distance formula in terms of line segments, but just looking at essentially a number line on 1 through 4. So number one says find the distance of PQ. So there's two ways to approach this. One of the examples you'll see is the first thing we're going to do is find the distance from P to 0 and the distance from Q to 0, and then add those two distances together, essentially utilizing what's known as the segment addition postulate, breaking PQ into two segments and then adding the two segments that create PQ. So what is the distance from negative 37.5 to 0? Well, none other than 37.5 units. And what is the distance from Q to 0 or 15.8 to 0? Well, none other than 15.8. So then we simply can add those two units together. And we get a total of 53.3 units. So the distance of PQ is 53.3. The other way to approach it, and I'll show that here on example 1, is to utilize absolute value. That's these bars that you'll see around a set of numbers. And what absolute value really means is how far is that number from 0? Well, how far is a distance question. So still talking about length of a line segment. So what we're going to do when finding the distance between two numbers on the number line, or even in the coordinate plane, we use subtraction. That's because subtraction is referred to as change. And we are essentially taking P and changing its location to Q and finding the distance between those two things. So we can take P and subtract Q. So the absolute value of negative 37.5 minus 15.8. Negative 37.5 minus 15.8 is negative 53.3 units. Now, most of you learned that when you see absolute value, you just learn to make it positive. That's because what we're really asking is how far is this number from 0? Well, since distance can never be a negative value, negative 5 or 53.3 is 53.3 units from 0. Now, some of you might be asking yourself, well, what if you find the distance from Q to P? So start at 15.8 and subtract 37.5, or a negative 37.5. So when we subtract a negative, we change it to addition. So that's the first thing I'm going to change. 15.8 plus 37.5 are the absolute value of. And when I combine those two numbers, I get the absolute value of 53.3, which is 53.3. So there are three different ways, if you look at it, to find the distance from 2 points on a line segment. So use any method that you see fit. Let's do the same thing on 2. Again, the first method we're utilizing is because 0 is between the 2 points on the line segment we're finding the distance of. So the distance from R to 0, the distance from negative 112.6 to 0 is 112.6. And the distance from S to 0 is 515.7. So we simply combine those two distances, thus utilizing the segment addition postulate, and we get a total length of 628.3 units. Again, just for those that like the absolute value, and it does have its merit, especially in the distance formula, we're going to do it the same way as we did here on method 2. So the distance from R to S, we're going to take the absolute value of negative 112 minus 515.7. Negative 112.6 minus 515.7 is a negative 628.3. And again, absolute value, we do change the number to positive always. But just keep in mind what absolute value really means is how far that number is from 0. So how far is the number negative 628.3 from 0? Well, it's 628.3 units from 0. And we arrive at the same answer that we did on our first method. Let's take a look at number 3 now. Now, the key change on number 3 is that 0 is not between t and q. So we can't necessarily find the distance from t to 0 and then q to 0 and add them. We could do it a slightly different way. We could find the distance and then subtract them. But I believe the easiest method here would just be simply utilizing the absolute value. So we're going to take point t, which is located at negative 42.8, and subtract. Remember, distance or length is a change in location, and so we utilize subtraction here, but we have to subtract a negative 8.7. So yes, I am going to write both negatives there. And the first thing I'm going to do is when we subtract a negative, we change it to addition. So that's the first thing I'm going to do. Negative 42.8 plus 8.7. So a negative 42.8 plus 8.7 is a negative 34.1. Now, because we did utilize the absolute value, the distance from t to q is 34.1 units, a positive 34.1 units. Now let's do the same thing with item 4, and then we'll move on to our second set. So again, 0 is not between the 2 points on our line segment, so we're going to utilize absolute value here. So we'll start with W and go to V and just show you that it's the same thing as if we started with T to Q. So we're going to start at W at negative 21.35 and subtract V, which is located at negative 89.72. So the first thing I'm going to do is change the subtraction of a negative to addition. And then take a negative 21.35 and add it to 89.72. And we get a positive 68.37. But the absolute value of a positive 68.37 is 68.37 units. Now, the other method I want to show here, because it's going to really tie into the next segment we're going to look at, pun intended, is how we can utilize the distance from 0 even when 0 is not between points V and W. So the first thing I'm going to do is I'm going to find the distance from V to 0, which, how far is negative 89.72 from 0? Well, it's 89.72 units. And then we're going to do the same thing with W to 0. So W to 0, how far is negative 21.35 to 0? Well, none other than 21.35. So notice what I have here. I now have this total length from V to 0. I have this total length from W to 0. And all I want, the distance that I'm really looking for, is from V to W. So when we have the total, when we're given the total, 89.72, the larger segment, and we're given just a portion of that larger segment from W to 0, we can subtract these two measurements to find the remaining length, or the actual portion that we're looking for, which is from V to W. So if we take the total largest segment, 89.72, and subtract this portion, 21.35, we will get that same distance we found here utilizing absolute value. We'll get 68.37 units. This is the segment addition postulate. Even though we utilize subtraction here, VW plus W0 or W20 is the length from V to 0. So utilizing in another way, even on the number line, the segment addition postulate, which leads us into our next section on item 5. So item 5 tells us to find the indicated length. Now notice that the portion that we're looking for is not from the two endpoints of our line segment, but just a portion of our line segment. So we should know, using the segment addition postulate, that MN, that length, when added to NT and added to TP, we get the total length from M to P. This is the segment addition postulate, where these three portions of line segment MP combine to create line segment MP. So what we just did here is we created an equation based on the segment addition postulate, and we're going to replace lengths that we know and find missing measurements. So I'm going to replace MN with 55.2 centimeters. I'm going to replace NT. I'll just actually, in fact, keep it NT. You can replace it with X if you want, or a question mark as you see there. I'm going to replace TP with 41.8, and I'm going to replace MP with 123.7. Now, many of you are not going to write a formal equation for this, but please understand that this is how we find that. Many of you, we just start punching things in the calculator, but this, we are writing equations. Some of us are just doing it in our head. So don't be surprised when it gets into algebra and we actually have to write a formal equation because, like I said, on item 5 and 6, we can write formal equations to find this. So we're going to combine like terms on one side first. And I'll bring down NT plus 55.2 plus 41.8 is 97, equal to 123.7. And if our goal is to find the length of NT, then we can simply subtract 97 from both sides, the opposite sign, and NT will equal 123.7 minus 97, which is 26.7. And because we actually do have a unit of measure here, I'm going to encourage you to put that unit of measure, 26.7 centimeters. We're going to approach item 6 the same way, finding QR. So we know that QR, that length, when added to the length from R to X and added to the length from X to Y, those three segments combined create this larger segment QY. So there's our formal equation, and I'm going to replace it with known values. QR will leave as QR. RX will replace with 15.7. XY will replace with 15.8. And QY will replace with 38.9. Approach it the same way we did item 5. We're going to combine like terms on one side. So 15.7 plus 15.8 is 31.5. So we'll bring down QR plus 31.5 equal to 38.9. Now to solve for the length of QR, we're going to subtract 31.5 from both sides, so that it cancels or becomes the number 0 on the left, and we get QR equal to 38.9 minus 31.5, which is 7.4. Again, we are given units, and this time, again, we're dealing with centimeters, so 7.4 centimeters. Now, again, many of you are not approaching 5 and 6 with a formal equation, but it's going to really come in handy as we look at 7 and 8. So let's dive into 7 and 8. So 7 says, find the length of GH if GH is congruent to HK. So the first thing I'm going to do is I'm going to show that these two segments are congruent. That's how we show that. GH is congruent to HK with these little marks. They also tell us that HK is twice as long, or 2 times the length, as KL. So whatever KL is, whatever length this is, the distance from H to K has to be 2 times that length. Therefore, GH also has to be 2 times the length of KL as well. So if we don't know a measure, a lot of times we can replace it with X. So I'm going to call KL, that distance, X. Well, they tell us that HK is twice as long as KL. So whatever the distance from K to L is, H to K, so HK will be twice as long as KL. So whatever the distance from K to L is, H to K is going to be 2 times that. Well, if we represented the distance from K to L as X, H to K will be 2 times X, or 2X. So the distance from H to K is 2 times X. Likewise, they tell us that GH is the same length as HK. That's what congruent means, for two segments or angles or lines or rays to have the same measure. So if we represented the distance from H to K with 2x, we'll represent the distance from G to H with the same measure. And last but not least, they tell us that the distance from G to L, the longest segment we're dealing with, what all these segments combined create, is 65 centimeters. So we'll write a formal equation. GL plus HK plus KL is equal to GL. We'll replace it with what values we created, or known values. So GL we'll replace with 2x, HK we'll replace with 2x, and KL we'll replace with x. And last but not least, GL we'll replace with 65. So we're going to combine like terms, which 2x, 2x, and x are all like terms because they have the same variable raised to the same exponent. So 2x plus 2x plus 1x is a total of 5x, and it will equal 65. Now to solve for x here, since 5 is multiplying by x, we'll divide both sides by 5. So we use this term cancel, but as stated in class, I don't really care for that. 5 divided by 5 becomes the number 1. And so we've marked through it because 1x we could simply write as x. 1 times x is x. So just please understand the distinction between canceling and becoming 0, canceling and becoming 1. 65 divided by 5 is none other than, I believe, 13. But again, what they're asking us to do is not even solve for x, because that's something we created to help us solve for the missing length. They want to know the length of GH. So if the distance from K to L we now know is 13, because x is 13, they told us that from G to H is 2 times that length. Well, what's 2 times 13? None other than 26. So the distance from G to H is 26 centimeters. So G to H is 26 centimeters. Now let's move on to our last question. Again, we're going to be utilizing some algebra here. That's why these formal equations can really benefit us. Item 8 says find DE if AB, BC, and CD and DE are what's called consecutive numbers. So consecutive numbers are essentially, when you're counting, one number right after the other. 1, 2, 3, 4, 5, 6, 7, 8, and so forth. So think in mind, or bear in mind, what does it exactly mean for numbers to be consecutive? Well, it's really a matter of a number increasing by 1 each time. So 1 plus 1 is 2. Add 1 to 2 and we get 3. Add 1 to 3 and we get 4, and so forth. And so what they're telling us is that, for instance, if the distance from A to B is 2, then the distance from B to C is 3, and the distance from C to D is 4, and the distance from D to E is 5. Now, clearly, it's not those measurements because they also told us that the distance from A to E, the total, is 78 units. So we're going to represent the distance between each of these smaller segments, each of these points on the smaller segments, using algebra. So we're going to start here on the left-hand side, not necessarily, I guess just the order of the statement we should assume to start on the left. It says A, B, B, C, C, D, and then D, E are consecutive numbers. First thing I'm going to do is I'm going to label A, B as X. So if the distance from A to B is some number, then the distance from B to C is that some number plus 1. Think about it, if AB was 1, well, 1 plus 1 would be 2. And again, 1 and 2 are consecutive numbers. But here's the trick here. Once we've already established that AB is X, we then have to say that CD is not just X plus 1 again, because that would represent the same distance from B to C. It would actually have to be X plus 2. Again, think of it this way. If X were 1, 1 plus 1 is 2, but 1 plus 2 is 3. So we would still have these 3 consecutive numbers. And likewise, the last one from D to E, if we did X plus 1, and X plus 2, DE would have to be X plus 3. Again, if X is 1, 1 plus 1 is 2, that'd be BC. 1 plus 2 is 3, which would be CD. And 1 plus 3 would be 4, which is DE. And so that's why we establish X, X plus 1, X plus 2, and X plus 3. Now we're going to write our formal equation. So AB plus BC plus CD plus DE all add to equal the total length of our largest segment, AE. This is the segment addition postulate. So I'm going to replace everything with the values that I assigned to it, or the values that they were given to us. So AB is X, BC is X plus 1, CD is X plus 2, and DE is X plus 3. And AE, they tell us the total length is 78 units. So we're going to combine like terms here. So X, 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 and X, these are all like terms because they are, in fact, the same variable raised to the same exponent. So this is 1x, 2x, 3x, and 4x. So we have a total of 4x. And then we have positive 1, positive 2, and positive 3. Those are also like terms, so we're going to combine those as well. 1, 2, and 3 combine to give us 6, 3, 4, 5, 6, equal to 78. Now we're going to subtract 6 from both sides. And I'm going to bring my equation up here just because I'm running out of room. So 4x is equal to 72. So we're going to divide both sides by 4. Again, it'll cancel or become the number 1, or 1x, and we don't have to write 1x. And 72 will divide by 4, and we get 18. Now, they didn't want us to just find x, just like we said on item 7, so keep that in mind. We created x to help us find what we're looking for to begin with. So they ask for us to find the length of DE. So DE in our algebra was represented by x plus 3. So if x is 18, 18 plus 3 is 21. So I'm just going to show you how this problem works by actually plugging in 18 to each of these algebraic expressions, just so you can see that it really does add up to 78. So 18 plus 2 is 20, 18 plus 1 is 19, and of course x is 18. So notice they are consecutive numbers, 18, 19, 20, and 21. And when you add 18 plus 19 plus 20 plus 21, you do get 78. So let's just make sure we put our final answer. DE is 21 units. So that is the end of skill lesson 17, covering the ruler and segment addition postulate. Thank you for watching. Hope it helped.